Hi students, welcome to the video lecture 3 on the topic transient heat conduction. So in the today's class, we will study what is the criteria for the lumped system analysis. So there are two main criteria. One is biot number and another one is the fourier number. So this biot number, it is the ratio of internal conductive resistance to the external convective resistance. So this biot number, it is also defined as a non-dimensionless number, and this biot number, it is a measure of temperature drop in the solid relative to the temperature drop in the convective layer. So it is also defined by this formula, that is biot number. It is the ratio of internal conductive resistance to the external convective resistance. Whereas this thermal conduction resistance, it is internal conduction resistance, is given by the formula L divided by K into A divided by this external convective resistance, it is given by 1 divided by H into A. So L divided by K into A, if I will take this to the numerator, should be H into A divided by 1. A gets cancels, so my biot number will be H into L divided by K. So in this biot number, I will write this biot number. Biot number is given by H into this L. I will replace it by LC. L suffix C divided by K, where H is heat transfer coefficient between solid surface and the surroundings, that is convective heat transfer coefficient, where K is the thermal conductivity, where this LC, it is the characteristic length, where LC it is represented by characteristic length, and this LC it is defined as the ratio of volume of the body to the surface area of the body, where LC is given by V divided by A, where V is volume of the body, where A is surface area of the body. So now let us study what will be the value of this LC for some common shapes. That is, for example, what will be the LC for plane wall, what will be the LC value for this long cylinder, what will be the value of this LC for sphere, what will be the value of LC for this cube. So now let us study one by one. Plane thickness. So this thickness itself, we have assumed it as 2L. So already I have shown it in the figure here sketch. So this is the plane slab. So this is my x-axis. So here if I will take this as the center line of the axis, from here I will measure L, and from here also I will measure L. So total thickness of the slab will be L plus L will be equals to 2L. That is plane wall which is having the thickness 2L. So now let us calculate the characteristic length value for the plane slab, that is plane wall, where LC is given by V divided by A formula, where LC is equals to V. V is area into thickness, where area is replaced by A only, into where 2L is the thickness of the slab. Area into thickness gives us the volume of the slab, where area both sides A plus A, this will be 2A, this 2A gets cancels, that is characteristic length LC will be equals to L for the plane slab, where this L will be equals to half the thickness of the wall. So in the problem, if the wall thickness is given as 6 mm, then L will be the half the thickness of the wall, then the value of L will be equals to 3 mm, where L indicates half the thickness of the wall. So now coming to the second shape, that is long cylinder which is having the radius R, where again LC, this characteristics length LC is given by V divided by A formula, where volume of the cylinder is given by pi R square L, and where A is given, surface area of the cylinder is given by pi into D into L, where 2 times of radius is given by diameter, pi into D into L or 2 pi RL, both are same. This L gets cancels, this R and this R gets cancels, pi and pi gets cancels. So my characteristic length LC for long cylinder will be equals to R divided by 2. Whereas the sphere which is having the radius R, this characteristic length LC is given by again formula V divided by A, whereas volume of the sphere is given by 4 upon 3 pi R cube. divided by surface area of the sphere is given by 4 pi r square. So again this r square and this r square gets cancels, pi gets cancels, 4 gets cancels. So my characteristic length LC for sphere will be r divided by 3 here. So similarly cube of each side having L, where characteristic length LC is given by V divided by A, that is volume of the cube is given by L cube, that is each side is L, that is length into breadth into height. So L into L into L, this will be the volume of the cube, this is L cube, and this is L into L, this is area of one side of the cube, and for cube it will be having 6 sides, so this is multiplied by 6 into L square. So each side of the slab, that will be L square will be the area. So total 6 sides for a cube, this will be 6 into L square. So L square gets cancels. So this LC characteristic length LC will be equals to L divided by 6. So all these formula are also available in your data handbook. So no necessary of remaining these formulas. So next we'll study. So already we have calculated formula for biot number. Biot number is given by H into LC divided by K. So if the value of this biot number is less than 0.1, then the lump system analysis is applicable. Then we can use this formula to calculate the temperatures or time. So now let us, already we know this formula, theta divided by theta naught is equal to T minus TA divided by Ti minus Ta, where theta equal to T minus Ta, theta naught is nothing but Ti minus Ta. This will be equal to exponential of minus H into A into T divided by rho into Cp into V. This formula already we have derived it. So now let me want to write the equation for this, whereas this H into A into T divided by rho into Cp into V. So I will write this equation in this form. In some another form I will write this equation so that the equation does not changes. So without making any alteration in the equation, I am going to write the equation in this form, where H into LC divided by K into K divided by rho into Cp into T divided by LC square. See, if we will simplify this equation, I am going to get this equation only. See here, K gets cancels, this LC and this LC gets cancels. So my equation will remain H into T divided by rho into Cp, where LC is given by V divided by A. So therefore this LC is in the denominator. If I substitute V divided by A, then in the numerator it will be A divided by V. So if I will simplify this equation, I am going to get the equation in this form only. So without making any alteration in this equation, I have written the equation in this form. Why I have written the equation in this form? Because I want to express this equation in some another form, that is biot number and Fourier number. So here I will keep the equation as it is, H into LC divided by K, whereas this I will write K divided by rho into Cp. K into rho divided by Cp is nothing but alpha, that is thermal diffusivity. Thermal diffusivity is given by the formula K divided by rho into Cp. This K divided by rho into Cp is nothing but thermal diffusivity, which is denoted by the symbol alpha. So this is replaced by alpha, and T as it is divided by LC square, whereas this alpha into T divided by LC square is nothing but Fourier number. So this equation I will write in this form. H into LC divided by K is nothing but biot number, whereas alpha into T divided by LC square is nothing but Fourier number. So this equation here, in this equation I will replace this H into A into T divided by rho into Cp into V by this equation, that is theta by theta naught is equal to T minus Ta divided by Ti minus Ta is equal to exponential form of minus biot number into Fourier number. So here only I have written this equation. See here, theta by theta naught is equal to T minus Ta divided by Ti minus Ta is equal to exponential form of minus biot number into Fourier number, where biot number is given by H into LC divided by K into Fourier number is given by alpha into T divided by LC square. So this Fourier number, like biot number, it is also a non-dimensionless number. So it is also sometimes called as non-dimensionless dimensionless timing. Sorry, Fourier number, it is like biot number, it is also a dimensionless time. So Fourier number signifies the degree of penetration of heating or cooling effects through a solid. So this Fourier number, it is very necessary to indicate how much degree of penetration of heat or how much degree of cooling effects has been taken place through a solid. So for a small Fourier number, so large time, that is T, is required to get the significant temperature changes. So this is about the Fourier number.